We will learn how to identify intercepts of a graph, how to graph linear equation by finding intercepts, how to identify and graph horizontal and vertical lines, and how to obtain information from intercepts.
Intercepts, Logical Evolution Part 2. Now we can graph a line if line is going through the origin, because we know table method and we know how to find x and y intercepts. And we are ready to write an equation of vertical lines and then for horizontal lines. After that, we will practice project graph the equation.
Problem. Find the x-intercept and the y-intercept of the graph of the equation. Positive 5x and negative 20y equals 0. We are looking for x-intercept first. So y is 0. Entire term with y is becoming invisible, and we will have 5 times x is 0. We have to divide it by 5 both sides. So x-intercept is 0 because 0 divided by 5 is 0. After that, we are looking for y-intercept. For y-intercept, x-coordinate of this point is 0. So term with y is visible and term with x is invisible. So we have to solve negative 20y equals 0. We have to divide it by negative 20 both sides. 0 divided by negative 20 is 0. So y-intercept is 0. Now we have to plot points in order to graph. So x-intercept is 0 and y-intercept is 0. They have the same spot. They share the same location. If you want to graph, look what will happen. Our line is not stable because it's only one point. To graph a straight line, we need any two separate points. How can we find second point? We have to pick whatever we have available for x. You can do whatever you wish. I pick negative 8. You could pick 1 or 2 or 3 or 5 or negative 6 or negative 5, whatever you want. So I pick x equal negative 8. And then I will try to replace x by negative 8 and solve for y. 5 times negative 8 would be negative 40. And now I'm moving negative 40 on the opposite side. So negative 20y is 40, or y is negative 2. So now I have a second point, negative 8, negative 2. I can plot this point, and now my line is placed in proper location. Your project is on the next slide after demonstration. To begin viewing demonstration for project, click play on the bottom of the screen of the next slide. Demonstration for project. This project has two parts. Find the x-intercept and the y-intercept of the graph of the equation 5x and negative 20y equals 0, and then graph the equation. I want you to work out the first part in your notebook on the side. I can do this on slide show. If we have an equation 5x and negative 20y equals 0, and we are looking for x-intercept, we know that y-coordinate for this particular point is 0. Then if you multiply negative 20 times 0, it's becoming 0. This is why we can copy this equation and pretend that you don't see negative 20y. You can see only 5x equals 0. Solve for x. So x-intercept is 0. After that, we are looking for y. The same idea, but this time first term is invisible. We have to solve negative 20y equals 0. We have to divide it by negative 20, both sides. 0 divided by negative 20 is 0. So then you can find y-intercept. And y-intercept is 0. Now we have 2 points, x-intercept and y-intercept, and both of them have the same location. In order to graph a straight line, you need 2 separate points, any 2 separate points. So now you don't have choice. In order to graph a line, you have to find second point. You have to select any value for x, whatever is available. I selected x equal 4. Then 5 times 4, because I replace x by 4, and negative 20y equals 0. Now I have to solve for y. 5 times 4 is 20. Negative 20y equals 0. I have to move 20 from the left to the right. And negative 20, y equal negative 20 divided by negative 20 both sides, so y is 1. As a result, I have one more point with coordinates 4 and 1. So now I can go back, and now I can graph a straight line, because practically I have 3 points. Let's plot the first one, x-intercept, y-intercept, you see the same location, and now point with coordinates 4, 1, this extra point. Now we have practically 2 separate points, and we can graph a straight line. Attach one end to point and extend line in both directions. And if you want to fix something, you can always do it. Now let's do what we're supposed to do from the beginning. X is 0, 0, y is 0, 0, and extra point is 4, 1. Now we're done. You can do your project on the next slide. Now it's time to talk about an equation of horizontal and vertical lines. Here is a vertical line, and x-intercept is negative 4, y is 0. Now I want you to look how we're graphing this line. You see, we are moving from the bottom to the top. We are changing y's, 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 but x stays the same. X is negative 4 for all points on this graph. This is why equation of this line x is negative 4. Now second line, x-intercept is 2. And again, if you're going to graph this line, here going from the bottom to the top, and x is all over the same. X coordinate is 2. This is why equation of this line would be x equal 2. It's easy this way. Next line, x-intercept is 8. Now we can show immediately an equation of this line, x equal 8. Furthermore, here is line which is going through origin, vertical line, and now we can show equation even for this vertical line which is going through y-axis. X is 0. This is how to write an equation of the vertical line. Horizontal lines. Similar approach. Here is horizontal line and y-intercept is 6. Now, if you want to draw this line, we are going from the left to the right, and as you see, for all points, y-coordinate is 6. This is why we can show this as equation. Y equals 6 for this horizontal line. Next line, y-intercept is negative 6. How can we draw this line? From the left to the right, x is changing by y-coordinates for all these points is the same, negative 6. This is why it will be easy to mark this line using equation y equal negative 6. One more line.
This line is going through the origin.
It's horizontal line, and this line is located on x-axis. Now, how can we show equation of this line? Y equals 0, exactly. So, horizontal lines, to identify equation, we use y-intercept. For vertical lines, for equation, we use x-intercept.
Problem. Obtain information from intercepts. We have a graph and then figure shows mileage data for a certain car. What information do the intercepts give about the car? First of all, let's look what we have on horizontal axis. Number of miles driven. And what do we have on vertical axis? Gallons of gasoline remaining in the fuel tank. Oh, this is very familiar situation, because we know first when we fill up the fuel tank in our car and then we will start driving, the fuel is decreasing all the time, and finally our fuel tank will be empty. Now let's look into this problem from algebraic point of view. We have an equation and we have corresponding graph. Let's talk about special points. The first special point is where graph crosses vertical axis. We would call this g-intercept in this case. And second point would be where graph crosses horizontal axis, and we would call this m-intercept in this particular problem. The g-intercept with coordinates 0, 18 indicates that when the car has been driven 0 miles, the fuel tank contains 18 gallons of gasoline. From practical point of view, this is how much your fuel tank can have. And then m-intercept with coordinates 600, 0 indicates that after 600 miles of city driving, the fuel tank contains 0 gallons of gasoline. Thus, 600 miles of city driving can be done on 18 gallons of gasoline. As you see, this is very interesting information and it's very helpful in our daily life.